Okay. Okay, boys and girls, we will continue our lesson number 17. It's about pressure in liquid. So last week we learned about pressure in solid. Last week we learned pressure in solid is P equals to F over A. P equals to F over A. Okay, so it will affected by the weight or the force acting on the surface and divided by the area. Okay, so sometimes the force at here they didn't mention, they give you in mass. So how we solve this question? We will make it in mg. Weight is equals to mg. Weight is one type of force. Okay, today we will learn about pressure in liquid. Okay, pressure in liquid. So a diver will experience discomfort in his body and ears when he dive in deep underwater. So why does this happen? Is because water exert pressure. Okay, liquid in pressure. So we will feel that hard to breathe. Okay, when we go deeper. So pressure in liquid actually is acting in all direction. And then you see the arrow size here. This one short, and then here become longer, here become longer. Okay, why? This one is showing you the pressure. Okay, the magnitude of pressure. So when we go deeper, actually at here, they will feel higher pressure, experience. Okay, experience more pressure. Okay, so pressure in liquid, what is the formula we use today is P equals to rho GH. This is not P, in pronunciation we call it as rho. Okay, rho actually is the density, density. So liquid pressure unit is same as previously we learned about pressure in solid. We call it as Newton per meter square, or we say Pascal. Okay. So these two are equal, equal. When I mentioning 1 Pascal, actually is 1 Newton per meter square. So for pressure in liquid also the same. This is Pascal, PA, or we say Newton per meter square. Okay. So here the depth. Okay, when we going down, the depth is in meter. Must be in meter, because here Newton per meter square. So this one must be in meter. Okay, then density. Density is, we know that previously we learned density is mass divided by volume. So what is the unit? Unit is kg per meter cube. So this one kg per meter cube. Okay, gravitational accelerations. Okay, this one is 9.8 Newton per kg. Question doesn't mention, but we have to know this value. Okay, 9.8 Newton per kg. So here, based on this formula, when pressure in liquid, it doesn't involve with any area in the formula, meaning that the pressure in liquid doesn't affected by the surface area. It's different as pressure in solid. Okay. So at here, you found that from here to here and this one to this one, as long as their depth here, touch at here for both cases are the same, no matter this one is larger surface area, here is smaller surface area. The pressure acting on this point, actually they're having same pressure. P1 equals to P2. Why? Because their depth are the same, it's the same. Okay, so at here we call this as depth is we measure from surface of the liquid until the point that we want to know. Okay, it's not from the bottom, then we measure going up. No, when we measure our height, we are measure from the bottom go up until your head part, right? But for depth is from the surface of liquid going down. Let's say I want to know what is the pressure at this point. Actually, the depth should be from the surface until this point. This is my hedge. It's not from the bottom measure going up. No, that's why we say this is depth. Depth is from the surface until the point that you want to measure. Okay, so we goes to page number 2. Pressure in liquid actually you learn in year 9 one. Okay, so we can come here. We got a few situations at here and can make some conclusion regarding the pressure in liquid. Okay, pressure in liquid will acting in all direction. How I know? Okay, if let's say I make some hole at the same liquid level, same liquid level, same depth, okay? Then at the end, we found out that the water spurt out at the same speed and same distance. Let's say here is 1 cm, here to here 1 cm, here to here also 1 cm. Okay, so as long as the pressure at any 2 points at the same liquid level, they will experience the same liquid pressure. Okay, same liquid pressure. So at here, if let's say here to here spur out as 1 cm, let's say here to here also another 1 cm, let's say only. So we can understand that actually if they having the same depth, okay, same liquid level, they will have the same pressure. Pressure will be equal if their liquid level is the same, okay? Then it will acting in all directions. So no matter at where you put the hole, the water will come out. So we understand that water pressure push the water come up, okay? So this one is the first one. So we know that acting in all direction, as long as they have same depth, same liquid level, the pressure will be the same. Okay, second diagram at here. Now we change. We want to study about the depth. Okay, the depth. So we found out that this one is from the surface going down until this point. Okay, we found out the water spurt out is the furthest. Okay, with the largest horizontal distance. So let's say here this one distance is, let's say, like 5 cm or x cm, whatever is the largest distance. So we found out that here to here spur up further, this one means that the pressure is actually highest. Okay, highest pressure. Pressure in the liquid will increase when the depth increase. So let's say I make this P1, here P2, here P3. We will find that P3 is greater than P2, greater than P1. Why? Because of the depth of P3, point 3, H3 is the depth 3 at point 3 is largest. Okay, so when you go deeper, actually the pressure of the liquid pressure will be increases. Okay, then we go down here. Now we got two diagrams. One is water, one is oil. So what we want to study actually is about the density right now. Okay, so the depth is the same. Okay, so supposedly should not label here lah. Okay, it should be labeled from here to here. This is our depth. Okay, from here to here, same depth is our H. Okay, then we found out that water will spur up further. So you can draw diagram something like this. Then oil actually will be something like this, shorter distance. Okay, water will be larger distance. At the same height, height is because they measure from the bottom go up. Okay, but I don't want to using this word lah, because we always P equals to rho G H. The H is called depth. Okay, water spur up further compared to the oil. So that means that water actually has a higher pressure. Why water has a higher pressure? Look at the difference for the density. Water density actually higher, so water will have a higher pressure. Pressure will be larger if the liquid has a larger, higher density. Okay, just now we study about the depth. Right now we study about the density. Okay, then we continue. If let's say we got different shape of container, then at the end we found out we pour the water in. Okay, we will find out that the water level actually are the same. They were having same liquid level. So that means that liquid pressure in liquid is not affected by the shape or size. Shape or size. Okay, it will not be affected by the shape or size. And also, just now I got mentioned, that's not affected by the area, okay? So can we go to your next page, page number 3? Okay, Okay, application of pressure in liquid. Okay, we already learned about pressure in liquid. We understand that when we go deeper, okay, so here pressure liquid will be higher. That's why you saw this arrow, the size. Okay, So it will increases. So when we want to build the dam, please make sure here you have to design a thick dam. Okay, so at the bottom part here, it will be thicker. Okay, bottom part of the dam will be thicker. The wall of the dam is much thicker than the bottom, so it can will than the bottom. The dam is much thicker at the bottom. Okay, so that it can withstand the high liquid pressure. At the bottom part at here, we need to build thicker is because bottom part actually go deeper, the hatch increase, pressure increase. So we need a thick wall to withstand the pressure. Okay, so at here, okay, deep sea diver need to wear special shoes. It's not just your swimming shoe, then you can go down. No, it's because high liquid pressure. Okay, pressure will getting bigger because there is more weight of water acting above you. So we need to wear special one, cannot just your swimming suit. Okay. Then next, water tank. Okay, water tank will be placed at the higher location. Okay, it will place at a higher location. It's because if like this, we can create a depth. Okay, here we can create the depth. So the difference in height between the water tank until the tap at here. So this one the difference. It will create a high liquid pressure. Water will be flow out when the tap is turned on. Okay, so this one we use the knowledge of the liquid pressure, so we make our life more easier. Okay, we make the water tank at higher position so that water can come out with a strong force. Okay, come out. Then here, last case application in our life. Okay, the fluid, okay, you goes to the hospital. So the fluid going into your body, actually how the fluid put allocated, it will located at higher position. Okay, higher position. So the difference in height actually same idea as the water tank lah. Okay, they create the pressure, they create the water pressure, make the water pressure high pressure, it push the liquid into your body. Okay, if let's say sometimes goes to the toilet, then you maybe take it out and then you hold it by yourself and then goes to the toilet. Suddenly it's lower than your certain position, body position, maybe your heart. Okay, then at the end you found out that your blood will flow out into the fluid bag instead of the fluid go into your body. It might be happen. So what's going on, what you have to do, you hold the fluid bag higher again, then the liquid will go back to your body again. Okay, so basically is we create the pressure difference. Okay, water will flow or fluid will flow from higher pressure to lower pressure. Okay, so basically the idea and concept is like this. Okay, page number 4. Pressure in liquids depends on your depth, your density, and gravitational accelerations. Okay, but gravitational acceleration is already fixed. As long as we are on our Earth, it will be 9.8 Newton per kg. Okay, it's a fixed value. Then it depends on what density, what liquid. Okay, then density will change, and then depends on how deep you go. Okay, so here, okay, boys and girls, dimensional container density is this. Okay, this one, the unit is not wrong. Just the way that we write in our IG is different. We will write kg per meter cube. This one also correct unit, but this one is we use in A level. Okay, A level. Now we are on O level. Okay, but both are correct. Calculate the pressure exerted at point X. Okay, can you try? P equals to rho GH. Rho is like this. This is the way how we write rho. Okay, do not write small p. Okay, boys and girls, can you try and then tell me your answer? At the same time, I want to take attendance. Crystal correct. Unit. 植花 no. 植花 no. Crystal is here, yes. 植花 Angeline. Crystal, yes. Yes. Okay, correct, Angeline. So P equals to rho GH. This is 1000 times 9.8 times this one, the H is the depth that I mentioned. So boys and girls, it must be from the surface of liquid until the point that you want to measure. So this is your depth. So it should be 3.6 minus 1.6. So at here, if we're using three significant figure, this will be our answer. Okay, in Pascal. Why in Pascal? Can you see that we are using in meter, kg per meter cube? Okay, 9.8 Newton per kg. All is SI unit. That means that the unit that we use at the end can be Newton per meter square or can be in Pascal. So if let's say here is cm, please convert it into meter. Okay, we must tally the unit. Okay, so next come here. Okay, your answer can be 2 to 3 significant figure. If 2 will be 20,000 Pascal, 3 will be 19,600 Pascal. Okay, here, reservoir, supply the water to the water tank. Okay, supply to here. Okay, water tank is here. Calculate the water pressure at X. At X is here. So which height you need to use? From where to where? What is the water pressure acting at point X at here? So try. I want to know which depth you are using right now for this case. Angeline, I think correct. This one I haven't count. Correct. One more. Oh, yeah. Wait. Oh, yeah, you need one more. 0. 枝花, correct. 枝花, the depth is correct. Emily, correct. Make it three significant figure. We don't know from where to where is the depth. We want to calculate pressure at here. So that means that from here going down until this point that we want to measure, this is your depth. Okay, this should be your depth. Crystal correct. 枝花 correct. Okay, if you study IGCSE past year questions, answer scheme will be on 2 to 3 significant figure. So we will follow the trainer. Okay, then here density is 1000 times the 9.8. Okay, times the height. Okay, it's from here until here. So this one is your depth hatch. Okay, so in total is 30 cm, 30 meter minus your bottom part here 16. Okay, so your answer should be 137000 Pascal, or in meter, or in Newton, or in the SI unit. Huitong correct. Okay. So here, these two questions want to tell you where we measure the depth is from the surface of the liquid until the point. Okay, until the point. Okay, now we can do the past year question. Just now exercise, now is your past year question. This one is very straightforward. Oh, one more thing I want to tell you. If you study the past year question before 2023, actually it's old syllabus. Their old syllabus, G that we use is 10 Newton per kg. So if you go through to 2000, before the 2023, you will find out that why teacher, the answer that I get always cannot get the correct answer. Actually, it's not your problem. It's because we're using 10 before that. So starting from 2023, we are using the new syllabus. We are changing the G become 9.8 Newton per kg. Okay, can you try with this question? This question very straightforward, nothing to trick you. And then I want to train you, must write formula substitution final answer with unit. Must. Correct. Angeline, correct. Hui Tong, correct. Megan, correct. This one very straightforward, 9.8. Then the H is 65. So at here, 637,000 Pascal. Okay, be careful with the unit here. Nothing to trick you. Meter, kg per meter cube, Newton per kg. So nothing to change. Okay. Crystal, yes, correct. Okay, dear, here. Okay, we got 3 container with the same base area. So here is the same. Okay, here same depth. Okay, keyword at here is same depth. Okay, which statement about the water pressure at point PQR is correct? So read it and then tell me which point actually is largest pressure, or actually they are the same. Crystal correct, Megan correct, Angeline correct, nothing to trick. Hui Tong correct. Hui Tong, be confident. Zihua correct. Emily correct. Okay, so dear, here answer should be the same. Okay, same pressure. Why same pressure? Just now the keyword here already mentioned because same depth. Same depth. Okay, so at here P equals to rho GH. This one is the same. G is also 9.8 Newton per kg is also the same. This is density. Are they using the same liquid? Yes, they are using the same liquid. They say water. So the density will be the same also. So everything is the same. So your pressure actually is the same at point PQR. Okay, that's why just now the statement we said that it doesn't affected by the shape or size. Okay, shape or size. And also doesn't affected by the area. Although they say that same area, but doesn't affected also. Okay, we go to our next page. Okay, this kind of question is quite often come out in the IG. So which bigger will give you the greatest pressure? We got 4 A, B, C, D. What do you think? Which one give you the greatest pressure? Angeline, correct. Very good. Zihua, correct. How about others? Crystal, correct. Megan, correct. Hui Tong, no. Later I explain, Hui Tong. Emily, correct. Okay, dear, here. Salt water actually is 1.1. Salt water is 1.1. Water is only 1. That means that salt density is higher. Salt density actually is higher than the water. So P equals to rho GH. If the density is higher, so your pressure should be higher. So that means that we need to choose salt instead of we choosing the water. Okay, greatest pressure. So density, we choose the higher density. That means that A and B, yeah. C and D first already we cancel out, okay? Then next, from A and B, which one will give you the greatest pressure on the bench at here? Here, can you see from here? Actually, the depth is greater. This one is smaller depth, okay? So this one answer should be A. Is it okay? Get it? Okay. Good job. Okay, then we go to number 4. We told you try one more time. Okay, so one is in seawater, one is in fresh water. Seawater is denser. So A, B, C, D, which one actually experienced the greater pressure? Correct, Angeline? Emily, no. Greater pressure. Correct, correct. Oh, correct, Emily, correct. Crystal, correct. Zihua, correct. Megan, no. Hui Tong, how about you? Seawater is denser. That means that seawater higher density. Megan, correct. Hui Tong, I'm waiting for you. Correct. You get it. Okay, answer is B. Answer is B. Because density higher and also the depth is greater depth. So answer is B. Okay, so seawater is denser. That means that density for sea is higher density. Okay, here, 2021. A horizontal metal plate of area. So label, this is area. Meter square, we also know is area. At a depth of 40 meters. So this one is the depth hash. Density of water is 1000. Gravitational field strength, so this is G. Most of the time, actually, they won't give. Actually, I think I give is because I don't want you use 10. Previously, this one is before 2023, so they're using 10. That's why I purposely mentioned. What is a downward force, F? Okay, on the plate due to the water. On the plate, this is a solid, okay? Acting on the plate due to the water pressure acting on the plate. So at here, how do we find P? Teacher, rho G H. How can I find the force? Any of you? What else formula we still need to use? Not only stop at pressure in water. Okay, after pressure in water, you count the pressure, then you can calculate how much force acting on the plate. Can you try? What else the formula involved with the force, area, pressure, and so on? Any of you already get the answer? Unit is wrong, Angeline. Unit is wrong, but value is correct. Magnitude is correct. Correct, Angeline. Be careful, Now it's downward force. It's the force. How about others? Only Angeline get the answer? How about others? No more. Any of you get the answer? Want to make sure you know how to answer. We can using P equals to F over A, dear. This pressure is the pressure acting on the plate. Okay, so the force acting on the plate area is 0.5. So that means that we can using this pressure in solid. And where is the pressure? The pressure is due to the water. You see, pressure due to the water.
Is it 196,000?
Yes, correct. Yes, correct. Okay, so at here, the 392,000, the force we don't know, the 0.5. Answer is 196,000, correct. Be careful with the unit, Just worry you careless only. Okay, I know you know that the force unit actually is in Newton, but some of the times we do a lot of Pascal. At the end, we use Pascal for our final answer. You have to, every time you write the unit, you have to look at it again, what we are calculating right now, what physical quantity we're calculating right now. Okay, we go to your page number 7. Okay, until here is it okay? Okay, we goes to the next question. Okay, this one is a diver. Okay, below the surface of water 50 meter, the density of water is 1000, acceleration of free fall is 9.8 meter per second square. Calculate the pressure that the water exerted. Okay, pressure due to the water exerted on the diver. So can you do calculation? Formula, substitution, final answer with unit. Okay, do not skip any step for the structure question. Formula, substitution, final answer. Crystal, yes. Angeline, yes. E equals to rho GH. 1000, G is 9.8. Depth is 50. Okay, so your answer should be 490,000 Pascal. Yes, Megan, correct. Emily, correct. Okay, 490, 1, 2, 3 Pascal. How many zero have to write it properly? Sometimes you press calculator wrongly, but when you copy it down, you will add one more zero or you will less one zero. That is a problem of students. Okay, so if 3 mark, final formula 1 mark, substitution 1 mark, final answer with unit 1 mark. Okay, the window in the diver's helmet is 150 mm wide and 70 mm from the top to bottom. Okay, can you calculate the force that the water exert on this window? Okay, can you do calculation? And then tell me your answer. Calculating the force that the water exert on the windows in the diver's helmet. So there is a helmet window here. Okay, what is the pressure? What is the force acting on it? Do your calculation and then tell me your answer. Angeline, no. Be careful with the unit. Here we need to be careful with the unit. So every time we are not just use the value put in the formula, no. We have to look at the unit. Okay, is there anything we need to do conversion or not? Is there any prefix? Try again and then tell me your answer. Y10, yes. 3 significant figure. Y10, correct. Zihua, correct. 3 significant figure. Y10, correct. Zihua, Y10, done. How about others? I already draw the diagram. This is what the question mentioning. Okay, 150 mm, and then from the top to the bottom part of the window is 70 mm. Unit is mm, you see. Emily, one more zero leh. The answer that you get is wrong. You got extra 1 0. Crystal also extra 1 0. Crystal also extra 1 0. Why? Okay, so for this question, P equals to F over area. The pressure that you do calculation just now is 490,000. The force we don't know. Okay, but the area at here, this is the area acting on this area. So you should using 150 times 10 power of negative 3. Then times 70 times 10 power of negative 3. Okay, here this value, this prefix is no value. This is a prefix. Milli is times 10 power of negative 3. You can use your calculator. Your calculator can help you for the prefix part. Okay, the calculator, we got one button called OPTN. You press 1 first. Then you press OPTN on your left hand side. On your left hand side, I think it's second button. Okay, then you click number 3, engineer symbol. Engineer symbol. Then go in and find what number is writing the small m. Any of you press your calculator and then tell me. The small m actually on your calculator for the engineer symbol part is one number so that your friend can press it. Any of you got calculator? Scientific calculator. If you got this function, you press 1, press OPTM, press number 3, engineer symbol. Then you choose, tell me which number actually showing the small m. Angeline 3, then 1. Is it 1 here? I don't have the calculator. My calculator lousy one. Cannot have this function, doesn't have this function. Crystal is 1. 1 here, 1. 1 showing the small m. Then at the end, at here, is it showing you times 10 power of negative 3? You press equals, then you should be get the times 10 power of negative 3. Yes, correct. Okay, for this one, engineer symbol, most of the symbol is already inside your calculator. You can find it through this method that I teach you. But there is one prefix doesn't included in, which is the C. Centi. This C is very common use in our physics. This is times 10 power of negative 2. It doesn't provided in the engineer symbol. So you have to know it by yourself. Okay, C is times 10 power of negative 2. Okay. Any questions? If no question, then we go. Oh, okay, here. After you do calculation, your force actually should be 5150 Newton. Okay? So for question B, this is for question B. Okay, any question? Click the reaction button to let me know that we can proceed to the page number 8. Zihua okay, Angeline okay, Megan okay, Emily okay. Yes, good job. Okay, dear, here. Okay, so this one is oil tanker in a river. Okay, the bottom is of the tank is the 50 meter below the surface of water, below the surface. So this is our depth. Okay, the area is, so this one is area, this one is the depth. Okay, water density is 1000. Calculate the pressure due to the water. So boys and girls, I want to tell you, actually at this point, they are not only pressure experienced due to the water. Let's say at here, okay, this point. Not only water pressure acting on it, but it's also having the atmospheric pressure. Here is water pressure. So the actual pressure, actual one actually is the atmospheric pressure plus the water pressure. This is actual pressure. But in this question, they say that pressure due to the water. So they don't care about the atmospheric pressure. They're talking about liquid pressure only. Okay? So if they want you to calculate actual pressure, they should telling you what is the atmospheric pressure right now. Okay? So I know it's 1 times 10 power of 5 Pascal is the atmospheric pressure at sea level. The question should tell you if they want you actual pressure. Okay, what is the pressure at the depth of 50 meter? If they didn't mention about due to water, that means they want actual. Okay, but here, pressure due to the water, I only want to know this part. I don't care about the actual, I don't care about the atmospheric pressure. Okay, can you try and then tell me? Actually, it's easy, just repeating. So when we do few more questions, then we understand. Most likely, they were asking this kind of question. Angeline, correct, correct. Hui Tong, correct. Crystal, no. Your value so big, too big. Pressure is equals to rho GH due to the water. Okay, so it's 1000 times 9.8 times the depth is 15. So at here, your answer should be 147000 Pascal, or you want in Newton per meter square also can. Okay, so Crystal, check which part the value that you substitute is wrong. You get it, huh? Okay, here, can you try? Calculate the force due to the water pressure on the bottom of the tanker. Angeline, correct. But if you want to write in this way, maybe we can change it into standard form. If you want to write, but okay lah, can be accept. I have to count how many zero for Emily. Correct, correct, Emily. Okay, so dear, P equals to F over A. 147000. The force we don't know. The area 6,000. Okay, the force at here, if you want to write in standard form, 8.82 times 10 power of 8 Newton. Yeah. If you write 0, then it will be 882, 123 Newton. Okay? It's the same thing. Crystal, yes. Megan, how many zero? Correct, correct. Megan, correct. Unit, dear. Every time practice to write unit. Formula substitution, final answer with unit. Okay, deduce the weight. How do I know, teacher? Normally, when we want to do calculation for weight, W equals to mg. This is the first formula that will come into our brain. Okay, but then here, we don't know the mass. Then how do we know the weight? We reread the question. So this figure shows the oil tank in a river, the bottom part. Okay, so there is no mass, yes. Okay, but then here, this one object is at rest. Object is at rest, not moving. Okay, this is not moving object. So if not moving object at rest, not moving. So this is balanced or unbalanced force. Do you still remember? The few chapter 2 or 3, we learn about force. This, if object not moving, is called balanced force or unbalanced force. Any of you can answer me? Balance or unbalanced? Zihua?
Balance.
Yes, very good. If balance, what happened to the force? Net force. What happened to the net force?
0. Cancel out.
Yes, very good. So your upward force will be equals to
0.
your,
Downward force.
very good. Okay, since the object, the oil tanker is floating, it's not moving. So that means that in this case, this is a balance force, okay? Balance force. So when balance force, net force is 0, that means that upward force must be equals to downward force. So at here, the force due to the water pressure at the bottom part, there is a force acting at here, which that's just now that we count in B, 8.82 times 10 power of 8 Newton. So it needs this force to support the oil tank. That means that the weight actually is equals to this value. That's why we need the same force acting upward. So at here, how do we know the weight? Since we cannot count W equals to mg because we don't know the mass. But from here, we know. Okay, so this answer is 8.82 times 10 power of 8 Newton. Is that clear? Click the reaction button so I know that we can proceed to the last page, page 9. Hui-Tong okay already. Megan okay. Crystal okay. Emily okay. Okay, good job. Okay, this question is 2023 question. Okay, it's new syllabus question. Figure 3.2 show the side view. We look at from the side, with a layer of ice floating freely on the water. Surface area. Okay, so this one surface area A. The mass of the ice is m. Then the density of water, this one is rho, is 0.45 below the ice. So this one is our depth. Calculate the point pressure at point X due to the ice and also due to the water. So they want to know this pressure due to the ice and due to the water. Okay, can you do calculation? What is the pressure due to the ice and what is the pressure due to the water? Ice, what formula you can use? Think again, ice is solid or ice is a liquid. So what formula you should use to calculate the ice pressure due to the ice? What is the pressure due to the ice? And what is the pressure due to the water? Megan, let me check. Megan, what you count is only for water. How about pressure due to the ice? Angeline, correct. Good job. Emily, correct. Add it up together, Emily. Correct. Good job. How about others? Zihua? Megan, what you count is solid. Yes, add it up together, Megan. Still calculating, Zihua, still calculating. Okay. So ice is actually solid. Some more what they provided to you is the mass and the area. Okay, so F is over area. So at here with the mass. So how do you calculate the force due to the mass? So actually here, the force actually can be the weight. W equals to mg. Weight is gravitational force. So it's also one type of force. Okay, so at here mg 690 times the g 9.8 divided by the area is 5. Be careful with the unit. Always look at the unit. Do we need to do any conversion or not? Okay, so at here 1352 Newton or zero point 0.4 lah. Okay. Then water. Water is liquid what? This is liquid. Okay, rho GH. So at here, this one is 1000 times the G 9.8 times the H is the depth. So at here, 4410 Pascal. Oh, sorry, this is not Newton. See? Even teacher also can make careless mistake. Okay, so every time we look at the unit and then we go back and see what physical quantity we calculate right now. Okay, so what is your pressure due to the solid plus liquid? So 1352 plus 4410. So you should get 5760 Newton. Okay. Not Newton, again Newton, Pascal. Okay, here I cannot say this is called total pressure. It's just pressure due to ice and water. Because if I mention total pressure, actually still need to include atmospheric pressure. Okay, but the question will be mentioned clearly due to ice and water. So we based on these two, do calculation and add it up together. If they ask you calculate the pressure at point X, calculate the pressure at point X. That's all. That means that they want total pressure, and they must tell you what is the total, what is the atmospheric pressure. Okay, so it will be giving you the value roughly like 1 times 10 power 5 Pascal. So at the end, you should add it up these three together for the calculate pressure at point X. Full stop. Okay, this is actual pressure. Actual pressure. Okay. So today we learn about liquid pressure. That's why we touch all the question is about liquid. That's all. But after we do few more, we do like few past year question, we understand that they like to asking you calculate the pressure. Then after that, use the pressure to calculate the force acting on the solid. Okay, so yeah, just be careful with the unit. Sometimes we need to do conversion, sometimes no need lah. Okay, until here, lesson number 17. Actually, we done already. Any question? If no question, you give me response. Then we'll go to lesson number 18. Huy Thông okay. Megan okay. Zihua okay. Angeline okay. Okay, Emily okay. Right, Krista, here is it. You want me to come back to here? Okay. So Crystal get my idea about this pressure in liquid. Okay. So have you done? Okay, now boys and girls, we go to lesson number 18. Okay, basically the chapter 6 we already complete. We comes to the new chapter about energy store and transfer. Okay, so we understand that actually energy cannot be created, cannot be destroyed. It can be only transferred from one form to another form. Okay, they will store as some form. Then after that, they will transfer to another. Okay, so at here, chapter 6. Okay, my sequence and chapter might be slightly different with your school because we are using different textbook. Okay, I'm using this is because my school is using this sequence. Okay, but doesn't matter with what kind of sequence, all the syllabus we will be covered. Okay, so here, energy is what we need energy to do work. Okay, early in the morning, I need to eat breakfast because I need to gain energy for myself, for my body to have the energy so that I can do work. Okay, so at here, energy is the ability to do work. So after that, next chapter we learn about next chapter we learn about work. Work actually is energy transfer. We have when we transfer the energy, we are doing work. Okay, what is the SI unit for energy? Energy is in joule. Joule. Okay, energy can be found in different store. It can be transferred between the store during the events or during the process. Okay, here, uh, what kinds of energy store we have? Energy that a body has due to its motion. When you are running, moving, whatever, what kinds of energy store? Hey, this one easy. Kinetic, kinetic energy. Okay, motion. As long as you are moving, running is about kinetic energy. Okay, then next, energy due to the height or due to the position. Okay, from the ground. If now you are sitting on the second floor, okay, actually you have this energy stored inside your body. So what kinds of energy due to the height or due to the position? This energy we call it as gravitational potential energy. Okay, it's gravitational potential energy. This is an energy due to your position, okay, from the ground until a certain height. Okay, so at here, third case, energy stored in the change shape of the object. If the object can change shape, then after that, when you remove the force, it will return back to original shape and size. Then this kind of energy stored inside the object is called elastic. Elastic potential energy, or we say strain energy. Rubber band. We pull, then we release. The rubber band will go back to original shape and size. Okay, because rubber band already store the elastic potential energy. Then spring also elastic potential energy. When you compress or you stretch it, okay, the spring trying to go back. Okay, until here, is that clear? Can we go to your page number 2? Wei Tong okay, Crystal okay, Megan okay. Okay. So here, what kinds of energy stored inside the nucleus of the atom? For example, uranium. What kinds of energy inside? We call it as nuclear energy. Okay, nuclear energy. Okay. On our Earth, okay, the nuclear reaction that happen is called nuclear fission. Fission. Okay, nuclear fission actually is splitting of the atom. Okay, splitting of the atom. So if let's say one atom at here, we got a neutron. This is uranium. Okay, neutron hit it. So it combined with the uranium, it become unstable. Unstable, in order to make it stable, it will split into two smaller nuclei. Plural for nucleus is called nuclei. And then some more got others reaction or others radiation, and also they're releasing the energy. This energy is called nuclear energy. For nuclear fission, in our year 11 we'll learn, okay, but right now is some idea and knowledge for you. Okay, neutron, we use a neutron to hit the uranium and make the uranium become unstable. So in order to make themselves to become stable, they were trying to split into two lighter nuclei. And also they will have some radiation. This one we will learn in year 11. And they release a large amount of energy. This energy is called nuclear energy. Atomic bomb, yeah? Okay, here. So object with charge. Okay, with the circuit, so electrical running, okay. Oh, what is this? Let me have a look. Object with charge like electron and proton interact. Oh, okay, they were having energy in their electrostatic store. This is electrostatic Store. Okay, energy flowing through a piece of wire when the switch is pressed on. Okay. Then next, chemical reaction will be happen. So what kinds of energy stored in the bone? So for example, the food, the battery, the fossil fuel, and also your body. Okay, inside your body, we eat the food, go in, our body will store. 此话 correct. Chemical. Okay, chemical energy store. Okay, next. The sum of kinetic energy and also potential energy. The kinetic energy is the particle vibrate. Okay, when particle vibrate, the particle will having the kinetic energy, and also between the particle, they will have the potential energy. Okay, this kind of store is called internal thermal. Okay, boys and girls are actually thermal is about temperature, right? Temperature higher, so it will vibrate more, so it will having a higher kinetic energy. For thermal actually is kinetic energy part, okay? But why internal? Internal actually is not only kinetic energy, but also got potential energy. These two, okay? But here internal part, internal store actually mostly is thermal lah, okay? More in thermal. Thermal is the higher portion, okay? Higher portion for the kinetic energy. But if we mention about thermal, we are only talking about kinetic energy. When we're talking about internal, actually we're talking about kinetic and also potential. Okay, higher temperature means faster particle will vibrate. Okay, so higher kinetic energy, it will having more internal energy because kinetic energy part getting more. Okay, so now we try with the past year question. This is 2013. A man pulling a truck of logs at a constant speed along a level path from P to Q, okay, against resistive force, against a frictional force. Okay, what form of energy stored in his body does the man use to pull? Okay, what form of energy stored in his body? Just now we got so many energy stored. So can you tell me? 子花 correct. How about others? Angeline, correct. Chemical. Okay, can you highlight body? Inside your body actually is chemical. Okay, chemical. So we goes to your page number 3. Okay, this one. Keyword. What type of energy store? Because bend, then release. Okay, so can you tell me what kinds of energy store? Correct, Angeline. 直话 correct. This is called elastic, or we say string. Okay, Emily, correct. Okay, next, this is 2022. Okay, this one is hydroelectric dam, so the water will flow. Okay, so at here, water will flow down. State the form of energy stored in the water. Water inside. Okay, water is what energy? Water gain what energy? Store what energy? Angeline, correct. 知花 no. Storing, not yet follow dear. 知花 I know my problem, okay? Because they store, then after that they only flow. So your answer should be before they flow. Crystal, no. Megan, correct. Okay, dear, here. Store in the water. Then after that, when we open the dam, then water will flow. If water flowing, that is kinetic, yes. But before it flow, here water gain what energy? Store what energy? Emily, correct? Zihua, no. Where got chemical? Zihua, no chemical. Okay, energy stored in the water in the reservoir. Okay, not yet flowing. It's my problem. Maybe just now I got mentioning about water flow. So this one before that is gravitational potential. Okay, basically for this case, since you mentioning about flowing, okay, so I can tell you that starting in the water is GPE, water. Then after that, water flow. Okay, flowing. So this one is kinetic energy. And then it turn the turbine. Turbine turn. Turbine turn. Generator turn. Generator turn. Turbine turn. Plus generator turns. So this one also kinetic energy. And last, okay, we generate electricity. So this is electricity. Okay. So this is how the energy transfer. This is how energy transfer initially due to the height or depth, okay? So water stored at here, it will have the GPE. Then after that, water will flow because it got the potential difference, okay? So pressure difference. So water will flow. When water flow, it's moving. So it's kinetic energy. Then it will turn the turbine here, turn the turbine. Turbine is connected to generator. Turbine turning, generator turn. So they are turning is kinetic energy also. Generator turn, it will generate electricity. How it turns and how it generates electricity, that is our year 11 topic. Not year 10, year 11 topic. Okay, but basically right now, water energy stored in water in the reservoir, not moving yet, that is GPE, gravitational potential energy. Okay, is that clear? Crystal, okay? Okay, Megan, Angeline, okay. Okay, dear, next. Emily, okay. Okay, number 4, leg track. Lifting a box. Okay, here. Okay, if let's say lifting a box. If I want to ask you what is the energy stored in the box? It gains what kinds of energy when lifting? Any of you can answer me? If let's say I'm asking about box, so what kind of energy it will gain? Angeline, correct. It will gain GPE due to the keyword called lift. Lift, that means that you move up from the ground. You move up to a certain height. Here I say certain height. Okay, position. So the box will gain GPE. But this question is mentioning that the electric motor, okay, is powered by a battery. That the form of energy stored in the battery. So at here, battery. Now I'm not asking you about the box. I'm asking you about the battery. So this is chemical. Is that clear? Then we goes to the next question. Okay, here. In which form is the energy stored by stretching a spring? Angeline, correct. Any others? Stretch the spring. Zihua, correct. Megan, correct. Hui-Tong, correct. Okay, no problem. B. Stretch. Keyword stretch. Stretching. Okay, next. Bicycle, we stop it using the brakes. What store will decrease and what store of energy will increase? Guess. Angeline, correct. Angeline, can you try to explain to me why is this answer for increases part? Why? Why you think that increase? Megan, correct. How about any others? Wow, nice. Your answer is exactly correct, Angeline. Good job. Okay, answer is B. Okay, just now I asked Angeline why choose thermal energy will increase. Okay, why? So Angeline say bicycle stop, the brakes have friction which generate heat. Yes. Okay, you using the brake to stop. Why it can be stopped? It's because it have friction. Friction will generate thermal heat. Okay, so when you hold your both of your hand and then you rub and then you touch your face, you will find that a bit warm. Okay, your hand, both of your hand a bit warm. That is friction heat produced due to the friction. Okay, so answer B is very good. Using the brake, so here you write it down friction. Friction will generate heat. Okay, then we go to your page number 5. Can we go to your page number 5? Okay, next. Energy transfer, okay, by different energy transfer pathway. So here we got few pathway. Mechanical. If you saw mechanical, actually involved with force. So we highlight force. No matter you pulling, pushing, stretching, squashing, all this about you applying a force. Transfer pathway is mechanical. Okay, so for example, the weightlifter starting what kinds of energy stored inside the body is chemical inside body. Chemical store. Weightlifter inside the body is chemical. Then after that, the weight will lift up. Okay, so this one is GPE, gravitational potential energy, gravitational potential store. Okay, then after that, this is mechanical. From here, convert to here. Okay, the pathway is mechanical. Then next, electrical. Pathway is electrical when a charge moving. Okay, charge is electron. Only electron can move. A charge moving. Here, the charge mentioning is actually talking about electron. Only electron can move. Proton, neutron cannot move because proton, neutron is hold strongly at the center. Okay, if let's say this one is nucleus, inside we got proton, we got neutron. Then outside at here, we got electron, So you see, the proton and neutron is hold strongly inside the nucleus. Okay, they got a very strong force holding them. Only electron is outside the orbit, so electron can move freely, easily, more easy to move. So at here, when we're talking about electricity, talking about the charge, only electron is the particle that can move, not proton. Okay, so inside the battery, we are chemical. Okay, then the filament in the bulb, what do you think? What energy, what energy store inside the filament? 纸花, filament got what energy store? This is the filament inside here. This one is called filament. Okay. Angeline, correct. Crystal, correct. Oh, Emily, no? Okay. Here, filament here, the bulb actually, they will become hot. Okay, so actually we're using the heat transfer at the end become light lah. Okay, So at here, what kind of energy stored in the filament? Okay, actually is called thermal. Thermal, or you say internal store also can. Yes, thermal. Okay, so next, heating. Pathway heating. Energy is transferred from a hotter object to a colder object. So this one, hot pan, when it become hot, so of course it's thermal. Or you want to say internal also can, internal energy. Then after that, the food, the thermal energy will transfer from the hot pan to the food. So the food now gain the thermal store. Okay, the pathway called heating. Okay, pathway transfer pathway is heating. Then one more here, heating by radiation. Okay, from the sun to our earth, the light transfer, okay, the energy transfer by electromagnetic wave. For example, our visible light can be transferred. So sun at here is what energy? Nuclear. Just now I say nuclear fission is about the atom splitting. Inside the sun at here, the nuclear reaction actually is nuclear fusion. This is fusion. This is another type. Two type only actually. One is splitting, one is combined. So this one is actually combined. The process is combined. So two hydrogen combine, then they become a larger nuclear. At the same time, they still have others radiation plus energy. Energy. Okay, here nuclear fission happen at the Sunday, not large scale on our Earth. No, it's because hydrogen plus hydrogen both actually are positive charge. They were trying to repel each other. If you're trying to combine them, they will try to repel because they're same type of charge. So in order to make this happen, combine the two same type of charge, make them combine. So we need to have a high temperature. High temperature, environment must be very high temperature, high pressure, and also the particle must be moving very fast speed. So this condition actually not yet able to be achieved at our Earth here. But our scientists, they're trying to keep on thinking how to run nuclear fusion in large scales on our Earth, so that we can get a lot of electricity, a lot of energy get from the nuclear fusion. Nuclear fusion is very, very powerful than fission. But on our nuclear power station that happen nuclear reaction actually is called fission, splitting. Just now mentioning splitting. For the sun at here is called fusion. It's combined. Okay, make two same type of charge to be combined. We need some certain terms and condition to make this happen. So we must make it happen in the high temperature and high pressure. But this one so far can be happen at the Sunday. Okay, on our Earth power station is called nuclear fission. Okay, so what energy we store? Okay, we get the energy, we get the thermal energy. Okay, or internal energy store. Okay, then we are going to your page number 6. We try with the past year question. Is it okay? We try with the past year question. No reaction. Okay, then we goes to here. This is 2023 new syllabus. What is the energy store for a mobile phone? This the diagram show energy store. Okay, so we got the chemical energy from the battery. Then how the energy is transferred between the store. So we will get the sound, get the heating. Okay, sound is because it will make the diaphragm vibrate. So it will have the kinetic energy or diaphragm. Okay, diaphragm will vibrate. Sound, how we producing sound? Vibration. Okay, wave, vibration of wave. So its vibration is kinetic energy lah. Then heating, internal energy. This what describe how the chemical energy is transferred, how this pathway, what is their pathway? Angeline, correct. From the battery until at the end. So in your handphone, mobile phone, actually inside is the A, okay, electrical, the circuit, okay, circuit is running. From the battery, we run the circuit, so we get the output. Okay, get it? Then we go to question number 2. Labeling wrong, okay, but it's okay. Can you guys try and then you type your answer in the chat box? Let me know your answer. Bicycle braking system transfer energy from kinetic energy store to an internal energy store. Then for the motor is convert energy from chemical energy store to a kinetic energy store. On motor, we switch on the battery, we close the switch. So at the end, something is moving. Kinetic energy. Zihua correct. Emily correct. Angeline correct. Okay. So braking system. You are applying the force, right? Okay, so it must be a mechanical work. Okay. Then after that, motor. Battery, that means that you run the circuit. So it's electrical. Okay, you switch on, close the switch. The battery is chemical energy. It run and then electrical work to make the object moving. Okay, lift up, put down or whatever. Okay, so here, this is 2023. This one is a candle burning. Describe the energy transfer taking place as the candle burns. Your answer should refer to energy store as well as transfer between the energy store. Okay, at start, your candle is what energy first? At first, candle contains what energy? Store. What energy store? What energy store in candle at start? Zihua correct. Candle, chemical. Okay, when it burns, so chemical stored in the candle actually will start to decrease. Okay, energy will transfer. Transfer to what? Can you guys try? Energy is transfer to, and what store energy? Okay. Angeline, yes, for the last point. Christoph, last point, correct. Surrounding the energy store is thermal energy will increase. Okay, surrounding you getting hot. So thermal energy will be increased at the surrounding. But we got one more point at here. Okay, they want you transfer. So this one starting, this one is ending the store. So in between energy transfer, they accept the answer as the light, electromagnetic wave. They accept radiation. Here is 3 marks. In between them. Okay, they transfer to the light energy. Then after that, at the end, what store will increase? Surrounding, you're getting hot, so its thermal store of the surrounding has increased. Starting chemical store, at the end is thermal store. in between in between the energy store, in between energy is transferred to the light or electromagnetic wave. In year 10, in the wave chapter, we will learn about electromagnetic wave. Inside the electromagnetic wave, they got 7 members. One of them is light. Okay, starting from radio, microwave, infrared ray, then visible light ray, ultraviolet ray, X-ray, and then gamma ray. They got 7 members. Then visible light is one of the member. Okay. Any question you want to ask me about today's lesson? Today's lesson quite straightforward lah. Any question? Give me response. If no question, we will end our lesson right now.